So, welcome everyone. Good morning, everyone. Good morning, everyone. Okay. The third time is always better. Good morning, everyone. Good morning. All right. Yes, that's the energy level that we need at this event, because at this event we are going to make history, or we can make history. And the reason is that it's a unique concept where we are able to, or we have the possibility to combine the strength of two prominent AI solutions. One that comes from the statistical-based approaches, the other one comes from the logic-based approaches. To do what? The purpose is to make AI solutions more intelligent. But those AI solutions have to tackle company challenges, concrete company challenges. So, why MAKEathon? There are three main driving factors that led me to conceive this MAKEathon. One is the scientific relevance of it. The scientific relevance because this combination between the logic-based approaches that commonly we refer to, or they embrace the knowledge engineering practice, together with the other hand, where we have, or the other approach, where we have the statistical-based approaches that commonly refer to the machine learning. So these two are not only something that are, theory up in the air. It's also that scientific community are really striving to drive the combination of these two. And this is what I observed at the Stanford University while attending AAAI-MAKE, where there is a community for artificial intelligence that is really keen into make the best out of AI solutions. This perfectly matches with the needs of the industry. Because the need of the industry, what we are facing at the moment is that they more and more want to have intelligent AI solutions. So here there is one of the most recent report from KPMG that interviewed 170 executives across the globe. And they came up with they interviewed, they surveyed these executives asking, what do you think about AI? What is the future? Give us some thoughts. And the report starts with this statement. Algorithms are playing an increasingly important role in business decision making, so it's essential that people trust those decisions. Well, the fact is we cannot trust decisions that cannot be explained, right? So, and if that is true, that also means that we cannot rely only on those machine learning techniques that reach conclusions that cannot be explained. This is what's happening with neural networks or deep learning. Good, the third driving factor of this MAKEathon is the so-called hype cycle for emerging technology that is held by Gartner, one of the most trustworthy research institutes in the globe, which is foreseeing the technology that are going to be applied in the future, right? And here says that there is one technology that is going to be applied, that is going to take off in industry from 2 to 5 years from now. And these are ontologies and graph. These ontologies and graph, for those that are not familiar with it, is the way of representing information in a machine interpretable format. And this refers to rather the logical-based approach, not the statistical-based approach. So this is what led to the creation of this MAKEathon. Now, in a nutshell, what makes MAKEathon so special is our and your passion, right? And then second of all, I would say the uniqueness of this concept, that in a sentence can be summarized as follows: a scientific and industry-relevant initiative aiming to generate innovative AI solutions that addresses global challenges by combining the strength of both prominent AI-based approaches, the logic and the statistical-based approaches. So if you're now wondering about this combination, do not worry. Dr. Martin Andreas and Professor Knut Hinkelmann are going to explain more in detail what these approaches are about and why we need strength of the two. Good, so this leads me to the schedule of these 2 days. And the first two are gone. Or we are going to, at 10:20, hopefully I'm going to be on time. We're going to hear the keynote of Dr. Andreas Martin and Professor Hinkelmann Knut. Then we are going to attend the pitching session of company challenges. We have more or less 1 hour. Each company is going to pitch 5 minutes the problem so that the makers can figure out which challenge can select. Then at 12 o'clock can start the group formation. At around 1, we are going to have a lunch break, not in this building, in another building that is called Ori. Breaking news is saying that it's going to happen in this building, so thank you, Maya. And even better, so we don't have to move a lot. For those who are not familiar with this building, I'm going to show a map now. Then we are going to have a dinner break at 7 p.m. So those who would like to stay, please let us know. I will tell you later how to let us know. Tomorrow we are going to start at 9 with coffee and some croissant. But for the brave who would like to remain here and code the whole night, because maybe they want to win the award, then we can let them, we can find a way to let them stay overnight. Then we have a lunch break tomorrow at 12. Then at 4 p.m. we are going to have the pitching session, but this time of the makers, so all the solutions on stage. Then at 5 o'clock we will start with the statement and feedback of challenge providers. So we want to see whether they are happy or not with the solutions, what can they can say about it. Then we're going to have an apéro starting at 6 p.m. This would give us a little bit of time to assess all the solutions and come up with the best MAKEathon 2020 award and the closing session that will start at 6:30. Good. Then the campus of Olten. On the right-hand side, so on your right-hand side, you can see the map of the ground floor of OVR, where we are now. So we are at the moment in the aula. Then you've got to know already Atrium B. That is where we can have some get-together, drinks. Then the lunch and dinner can take place in the canteen, which is below or further down the canteen, the cafeteria. And that's it. These are the most important spots to know, plus where to work physically. So we have a few rooms that we are booked for you to collaborate. Please try to stick to these rooms, otherwise we run into problems with the facility management or FHNW. These are the possible rooms. I'm going to upload these slides later in the general channel of Microsoft Teams so that everyone can see it and is aware of it. Then we are going to recognize ourselves via badges. Probably you already have seen that all the makers have a yellow badge. Then we have the mentor has a blue badge, the staff blue light, and then we also have mentor and staff blue and blue light. We have the sponsor red, the challenge provider light red, sponsor and challenge provider both red and light red. And finally, guest. Good, show your badge and get your lunch today. Not in Ori, but in the canteen. Now, makers, you are not alone. This is also another thing that makes this MAKEathon unique and special, because you get support of a pool of experts. So the first pool of experts comes from the scientific world. So we are all aware here of this MAKE, or this combination between the two AI prominent approaches, and we can give you guidance in designing these innovative AI solutions. So we have Professor Knut, Hans Friedrich, that we call Frieder, Andrea, Stefan, David, Charuta, Maya, and myself. Then we have also a pool of mentors from the industry. And here we have Michael and Mark coming from IPT, one of our sponsors. And then we have Florian coming from Microsoft. They are experts, DevOps experts, so you can rely on them when actually implementing the challenge. They are going to tell you how to redeem vouchers of Azure so that you can work on Azure free of charge with these vouchers and use all the possible computing power of it. So please refer to Michael and Mark to redeem your voucher as soon as you start implementing the challenge. Then, what we have also is a MAKEathon Azure Starter website. You can look into it. You will find all the possible information to implement the challenge from the machine learning perspective. So you have several APIs that are available for you to implement the challenge. Plus, you have also a small video from Florian that is welcoming you, plus giving you guidance towards the whole concept of this website and how you can use it in order to start implementing the challenge. Then, collaboration. We are going to use MAKEathon Microsoft Teams for the collaboration. In the general channel that looks like this, now we already have a couple of communications. We are going to provide the main general communications. Here we are going to display or set a call also for the remote challenge pitch. And the reason is that some of the challenge providers ask us to keep them private, and therefore we cannot publicly display this. That is the reason why we set a private call here, and all the participants that are now following remotely can jump into the call and see the challenge, the pitches of the challenge providers. We are going to create new channels for you here. So for each team, one channel. In this channel, you can collaborate. Then, how do we know to which team you belong to? Well, there is an Excel sheet to fill out. I already placed it in the general channel. You click on the link. You will be directed here. For each participant, you have other information to provide, such as the GitHub username and email, the team name, whether you want to attend dinner tonight, lunch tomorrow, or whether you want to stay overnight. Then we also prepared a GitHub repository for you called GitHub MAKEathon. I can give you a bit of time to scan the QR code, otherwise you can just find them in the general channel. And then important information for makers. So some challenge providers will hand in a non-disclosure agreement for their respective challenges to be implemented. That means if you select now this challenge and you have this information, you know that this challenge provider wants to sign this NDA, please respect that. Otherwise, if you don't feel like doing that, perhaps change challenge. Then makers can use any technology to implement the challenges. You're not obliged to use any specific challenge. Please make sure that the challenge provider agrees with you with your choice before starting implementing the challenge. Then finally, important, the deadline, Sunday, 3:30 p.m. That's the deadline that you have to submit the challenge, or the solution, not the challenge. To submit the artifact, so meaning the software code together with the presentation. Then we have half an hour where you can relax, calm down, we drink a coffee, and then we start with the pitching session at 4 p.m. Good, then we are going to have the Best MAKEathon 2020 award tomorrow. These are the evaluation criteria for the AI solution, so that you are aware of it already. First criteria is to which extent this AI solution is relevant to the challenge. Second criteria is innovation. Is it innovative, this solution, or it's something that is already existing, which includes probably the same drawbacks? To which extent do you embrace this MAKE approach? So this combination between logic and statistical-based approaches. Good. So now a big thank to the sponsor. Gold sponsor PostFinance, silver sponsor IPT and Vega, and finally bronze sponsors Indaja, SecPy, and De La Cruz Beranek. Big thank also to our partners, the technology partner Microsoft and communication partner Swiss Dev Jobs. And finally, my message is let's try to be as energetic as possible to really sign this milestone of a new area where we can jointly put effort, scientific world and industry together for a common objective to make these AI solutions more intelligent and valid and relevant to address concrete challenges. Here you have a QR code that leads to the Facebook channel where you can always be updated and see comments or pictures of the MAKEathon, and you can be aware of what is going on. Good, so thank you a lot from my side for your attention. Now I would like to hand in to Professor Knut Inkerman for the keynote. Do you have it here?
Can you wait? Sometimes this does not work. We have this. Does it work?
Yeah, it works.
Good. So, welcome also from my side to this MAKEathon. I see a few familiar faces that I did not see for a long time, and many new faces. I like that. So, I was asked to give a short keynote. I will try to make it short. I want to give you an introduction in the idea how we came up with that. And I want to do it from the perspective of what we can do with our brain. So what is intelligence, how we can look at it. So this is a quote from a guy who's one of the founders of AI. The brain happens to be a meat machine. What is the idea? The idea is that we can build an intelligent system. Our brain is a machine. Can we now build also a system, a machine that acts like the brain? So that's why it is called artificial intelligence. And what is now our human intelligence? When we start from that, from human intelligence, we can think of it from two ways. On the one hand side, we think ourselves we are rational people. Yeah, we can make decisions and we can reason about something. So when I go from here to Zurich, I know what I can do. I can take the train and I can do so. We are rational people. We can also make arguments. We can discuss. This is one way of thinking of our intelligence. And there's another way to think of intelligence. We are a machine, or our brain can process huge amounts of information. I try to visualize that with information that we see with our senses. We see it, we hear things, we can read, we can deal with huge amounts of data. So these are two ways how we can think of intelligence, and a lot of work that's going in that. When we now look at this from the perspective of artificial intelligence, so what is artificial intelligence? It started in a workshop in 1956 in Dartmouth. This is where the term artificial intelligence was used the first time. And they want to build such an intelligent systems that acts like we as humans. So the first phase of AI really dealt only with this rationality, building rational machines. So it goes around until mid of the 80s, and the practical applications in that time were expert systems. Systems that are as intelligent as an expert in a specific area. So having a look at it could look like that. We have the experts, we get the knowledge of the expert into the system, and now people who are not experts in an area can use the system, have the same knowledge, and can make the same reasoning as the experts can do it. So here in the example of medicine, we can find a therapy or diagnose a disease. So this was until mid-80s, beginning of the 90s, and then it dropped. So there were not many applications. So this is what people now call the AI winter. So, but why was this AI winter? Yeah, there were many things that we cannot deal with these applications like expert system. For example, driving a car. I found a quote, it's not that long ago, 14 years. So for me, I'm old enough, for me this is not long ago. So it is hard to imagine discovering the set of rules that can replicate the driver's behavior. How can we get the knowledge of the drivers in the system so that the system can behave like a driver? Can we do that? Do we have the knowledge? Okay, this was something that is not possible. Another example is face recognition. I recognize your face. I said before, I see some familiar faces even with the masks. Yeah? I can recognize that. So we are good in that, but the machine is not good in that if you would represent the rules, if you would explicitly describe how I can recognize Francesco again. Okay, well, how does it look like? Yeah, it's difficult. We cannot describe it. So this is why? Because we have a lot of information that we have to process at the same time. And this is the second kind of intelligence. So this is where the rise of artificial intelligence, we started now in the 2000s. We use statistical machine learning, and we can process huge amounts of data. So we have two kinds of intelligence. And in the history of AI, we had first to focus on rationality. Now we have to focus on processing huge amounts of data. So you already see what happens. Why do we split these two things? We as humans can deal with both. So, but this statistical machine learning has a lot of advantages. Think of the deep learners for recognizing obstacles, which we need for driving a car, face recognition, what I mentioned, diseases of cancers, looking at all the images and finding out where's the cancer or which image has the cancer. Or translation, at the beginning it was the idea to define all the rules for the translation. Now with statistical data we can learn translations. Even pictures we can translate because we identify the text and then we make the translation and change the pictures. We can recolor pictures. So these are applications for the recognition, but also for composition, for creative things. There are machines that can produce music based on all music that they know. Okay? So if we have this, and we can do a lot of nice things, but the problem is this is not rational thinking. So can decisions without explanations be intelligence? So we make a decision, this is cancer, and we do this and that, and we don't get an explanation for that. Would we trust in that? Yeah, so I have this example. Yeah? We have a diagnosis, and the machines are very good in that. They can recognize that there is a cancer. But now we have the therapy. And now you're a doctor, your physician comes, yeah, you have to have a surgery here for the cancer, directly behind your eyes. Would you trust that without having an explanation? Wouldn't you like to discuss what are the risks, what are alternatives? Okay, so this is where now rationality again comes into the play. And the idea of us is that we can combine machine learning on the one hand side and this knowledge engineering on the other hand side. And there are examples when we take this medicine. Yes, we have the machine learning to do the diagnosis with a lot of data from which we can learn. And then if you decide for the therapy, we use also expert knowledge. This would be a combination of this machine learning and knowledge engineering. Or another explanation, access control. We talked about face recognition, but to tell if the face is recognized, what is this person allowed to do? And what is this person not allowed to do? This is not enough to just recognize the face. So we might have a reason why someone is allowed to do something and not another thing. So the access control is something that comes later. And this is what we decide consciously, not by machine learning that someone has access to data that is proprietary. Okay, another example of the self-driving cars. We recognize the obstacles based off the data. We can do driver's behavior. But there is a lot of knowledge that we cannot learn. Think of the traffic rules. Yeah? That you have to stop at the red light. What if traffic rule changes? Then from the one day to the other, the system has to behave to the new rules. There's no time to learn. Oh, sorry, we don't have enough data. We can follow the rule next year. Okay? So we change the rule, and from one day of the other, we have to follow the new rules. This is something that we cannot learn. And we decided for the new traffic rules. It's not by chance. So that's where knowledge comes into the play. Or credits and insurances. Yeah, we have the problem of the risk. On the one hand side, we want to have a benefit as a company, so we have risks and profits and loss. From this, we can derive the risk. And this is based on data, maybe. But there's also compliance. We have to follow rules. Think of all the compliance that we have in the financial sectors. We have to make sure that we follow these rules, that we are compliant with the regulations. Both things together make a decision whether we give a credit or whether someone can have an insurance. And this can also map into a system. So we could have a system that says if the risk of the person is low and the person is eligible for this insurance, then we can accept this insurance. So we have a combination of both. And the risk, this could be learned from data, having a lot of data of people that with their diseases and all the patient data, and then saying whether we spend a lot or not as a company. So we use this as the data. And for the compliance, we have to make sure that we are compliant. We use the knowledge of the people to express the compliance rules. It's another example of combination. Our final example, this is this thing that we did and what I really like because I like whiskeys. So I was in a whiskey fair, and we were discussing with the experts, what whiskey can you recommend? And we typically have a discussion. Yeah, so we have the expert that tells us what would you like, what do you prefer, but I have also this and that is similar, and so on. So we tried to make a system for that, so we wanted to have a kind of a virtual bartender with whom we can talk. And if you talk, it is not just data, and we want to discuss this with the people. So what we did, we developed a system that on the one hand side uses the data about preferences, so customers who bought this also bought that. Yeah? But we have a lot of products in that area that are new, where we have limited editions and so on. So then we cannot make a decision based on the old data. So then we use knowledge. There's the expert knowledge. There's a book about whiskey or books about whiskeys. We know in which regions which whiskey is, what are the distilleries, what are the different kinds of fabrication, so we can compare things and so on. So this is where we use expert knowledge. And then we build a system that combines the recommendation based on the data with the knowledge. And then we can talk with the system. So we built this kind of a chatbot. So these are applications that I wanted to tell you that are examples of how we can combine data-driven AI with knowledge engineering, knowledge-based AI, where we have rational thinking combined with the processing of huge amounts of data. And this is somehow what we had in mind when we discussed about this MAKEathon. And Andreas will now show you another example about how we can combine this and what machine learning really means.
So, welcome everybody from my side. Thank you very much that you are joining this exciting event. I would like to give you some explanation, a little bit of reasoning, why MAKE makes sense. So that's the idea here. And at the end of the day, or at the end of my presentation, you should know why it makes sense to combine machine learning and knowledge engineering. This presentation, similar presentation I was giving at our first session of the AAAI Symposium at the Stanford University 2019, where Knut and I initialized that symposium about particularly this topic, machine learning and knowledge engineering, and combining those two things. And I must say, I start with a story. And you know, I'm actually from the university here, and I start with a not so scientific story. The same story I also used there at Stanford at the first time. So it is a little bit, so mind the gap between research and my personal observations. And preferred use is actually at the coffee breaks to discuss about this. And yeah, I will talk a little bit, and maybe I will overrate certain things because it is about this image. And at the beginning, it's about these two guys. On the left side, that's me, and on the other side, that's my son. It's actually not so important that it is my son, so I will always think that my son is the most intelligent person on earth. To tell you this, every parent will think about this, I assume. So it's an average intelligent person, I would assume, so we can assume that it is. But what I saw there is actually, he is there around 1.5 years old, and I experienced how children learn. And this story is about this. So at the beginning, when you are a young child, it's as a little boy, or of course also as a girl, it's all about this, about airplanes, right? About helicopters, cars, and so on. So you try to recognize the world and identify the things there. So you learn. And actually, at the beginning, it's everything about knowledge engineering on one part, on the other side, it's about learning. So you are building knowledge bases as a young child. So you start with building knowledge bases, You see a helicopter, you see an airplane, you see a car, and then you are trying to interlink that. This is a knowledge base, right? You can also, you start also thinking about relationships, right? How those elements are related to each other. You start rethinking what you see the second time, right? And then you are updating your own knowledge base. And sometimes it happens that you have new things which you recognize, which you would like to generalize. You generalize stuff. You do that implicitly, of course. Here we have some kind of an ontology. But my son is doing that just in his mind. And maybe natural, and in my point of view, artificial intelligence is about building ontologies on one side. So now it's the question, what is about things you don't already know? What is my son usually doing? So we have something. We know that aircrafts land on the ground. It's a vehicle, and so on. And now he sees an airplane, and it makes like this. It does not land on the ground. It makes like this. And he doesn't know how this is called. But he has a knowledge base already. I'm living in the Ural Mountains, so he already knows something about climbing up mountains, about climbing up trees, of course. So he knows that this is actually climb up. And now he makes something magic, actually, in my point of view, is actually he tries to extend the knowledge by playing with the language. So what is actually the airplane? What is the airplane doing? What do you think what the airplane is doing from the perspective of my son? It's actually, and combining it with this knowledge here, it actually lands up. This is something when you have a young child, or you see a child playing with language, he tries to combine what he or she already knows and then tries to transfer that knowledge somehow. Of course, it's not lands up. We can, as a parent or as an adult person, we can tell the children, okay, maybe it's not land up. But however, it is happening some kind of magically, this learning, right? And we can relate that also, in my point of view, to machine learning as well. So at the end of the day, we have, I've told him, it's land up, it's a nice try, actually, of this airplane. We will call that takeoff. Good, so machine learning. So this was the magic learning. I would call it as the magic learning in my point of view from the human perspective. What we have in the artificial perspective, we are having this machine learning. And we know it's so powerful and it's impressive. It's absolutely impressive for me always to see what's actually possible. And so maybe we want to distinguish something with it. We know that we can, for instance, classify images and so on, and see what's going to happen. So what we need for a machine is a vast number of labeled data. We know this. Now I make the link back to my son. His magic learn is actually only requiring one good example. So usually that's the case. Only one good example to recognize a new element, a new entity, a new object. For instance, here he has immediately learned what does it mean to have an airplane, or what does it mean to have an airport, right? One big example, a good event actually as well, then he has learned this. But in contrast to this magic learn, for machine learning, we need a lot of data, right? So we can think now about it. What is actually intelligent here? So machine learning needs a lot of data for the same thing. My children, we as humans need 1 or 2 good examples. Then we know it. So now we can ask, what is actually really intelligent here, and who is more intelligent? In my point of view, it's still a little bit more the human, because they are storing knowledge and using knowledge. They are having knowledge bases in the back. This is explicitly the reason why we should combine it. So, and additionally, from the machine learning side, it's also very difficult to explain that for it to explain something. We have an algorithm, we have some values tuned, weights tuned, but for explainable AI, we still have a little bit an issue here. Then it might be happening that it even recognizes the wrong thing, a machine learning algorithm. Here's an example made from colleagues where they changed a little bit the angle of the object to recognize. And I think we can recognize that it is a fire truck upside down and not a bobsled. So we have some difficulties in machine learning. And it's even maybe learning the wrong thing when we just apply pure machine learning. It's an example again from colleagues. Here they benchmarked machine learning algorithms to recognize certain things. And what they recognized, actually, the researchers, is that it sometimes happens that it's not clear what the machine learning algorithm is actually learning. They made an example where they have on the top images some copyright on the image. The machine learning algorithm learned this, but actually it should have learned the horse and the car, but it learned the copyright. So we cannot direct the learning. That's also an issue. Compare that to my son, to children, we can tell him, listen, this is a table. We can direct the learning using its already provided knowledge, using already the knowledge base which is available. Now it's a question whether so he needs just one example, right? We need one example, we direct the attention, then it's clear that's the airplane, that's the airport, and then it's not the copyright he learns, actually, from the images he sees, actually. And we can actually teach this to machines too. There's an approach released also in 2019. It was after our first Stanford symposium, AAAI symposium. These colleagues trying to incorporate semantic relationships into the machine learning algorithm. They are providing some kind of a filter where you can pre-filter actually, let's say, the image. So put the attention on something specific and actually put the attention on something specific from a question you might have. So we can direct the learning. It's possible, and you have to maybe extract a little bit of semantic information, maybe building a certain knowledge base. Okay, back to this image. By the way, I also have an update from the next year of this image. The first image, by the way, it's not an Instagram fake image. It just happened. My wife didn't tell us that he will take an image. This one is an influencer image. Yes, we were standing there and my wife took it. But it's actually not so important about this. I'm talking now about the background, the winter. So when it is cold, I like the winter to ski, right, and to slide somewhere, right. What I don't like is the AI winter. And this is the final topic which I would like to talk with you about this. You have heard it from Knut, right, what the AI winter is. And it happened twice, this AI winter. And now it's a question, what is going to happen with the focus on machine learning? Many people are saying, okay, it's going up, up, up. Maybe, that's true. But what is actually with the computing power? So it happens, it's also research from colleagues. They try to interlink actually the computing power available, the hardware performance that is available with the demand of deep learning. And we see there is some kind of an issue going on. Okay, we can always say we will have better algorithms in future. We can always say we will have much better hardware in future. We can also bet on quantum computers. They're not yet available for deep learning, for this deep learning applications. We can always bet on it. Okay, we can. But now we are at the moment having the issue that it's demanding a lot of computer power, and maybe it's even not make economically and environmentally make sense. So, for instance, from the University of Washington, they trained a fake news detection model. It cost them around $25,000 to train it. Then the recent released OpenAI natural language generation or language model, the GPT-3, cost approximately $12 million to train. Okay, we can say for big tech, that's not a big issue. But what about lowering error rate? For instance, in image classification. Also something colleagues calculated. Here we have the error rate. And if you want to lower the error rate, it can cost you tons of money, actually. And the second element I would like to quickly highlight is actually also the environmental cost we might have of machine learning, of pure machine learning. So the question is now, does machine learning alone make sense? And do we really need to machine learn everything from scratch? And I would say no. Of course, there are pre-trained models, we know this, there's transfer learning, this concept of transfer learning as well. But my son is not machine learn or human learn everything from scratch. He is using a knowledge base already. And we should do that also in artificial intelligence. So humans don't learn everything from scratch. Why should actually machines do that? So therefore, let's combine machine learning and knowledge bases, knowledge engineering, and create something fantastic. So why make sense? Because it does. And it's natural and adequate for artificial intelligence too. Thank you very much.
Good. Thank you very much, Andreas. So I would like now to switch off the public transmission so that we can start officially the pitching session of challenges. So we are going to move all the virtual pitches at the very end. So we give a little bit of time to those who are at home, especially from Vega, to connect either with Microsoft Teams